Welcome to lesson 9. I'm going to have you pause the video and work out this warm-up problem. All you're doing is filling in the table. If it's missing a percent going across, like this first one right there, 1/4 is 0.25. You need to write that as a percent. Next one, you need to write that row as a fraction, write it as a decimal. You're just filling in the missing spots in the table. When you're done, unpause the video and then see how you did. So, for this first row, anytime you're going from a decimal to a percent, you are moving the decimal 2 spots to the right to get the percent. And you're going to need that percent symbol, because if you don't write the percent symbol, you're just saying 25, and this is definitely not 25, it's 1/4. For the second one, if you have 1% or 0.11 or 0.01, excuse me, that's 1/100th, because remember we have tenths place and then hundredths place after the decimal. Or however many spots are after the decimal is how many zeros are in the bottom of that fraction. For this next one, as a decimal number, this is going to be 0.40. Okay, you could multiply that by 2/2 to get 4/10, which is how I have that written here, and then I put an extra 0 on. Or from a percent going to a decimal, you go left 2 spots with the decimal. From where the percent symbol is, left 2. Next one is 75%, and then if you put 6/10, that's okay, but a better answer is 3/5, because that is our simplified fraction. Going from this fraction to a decimal, you would have to divide. I don't really want to do that, but I know it's 0.125 because I take this decimal and move 2 spots to the left. Okay. On this next one, I have 1 out of 1,000. There are 3 spots after the decimal. Okay, this is the same thing as 1/2, which would have been a better way to write that fraction. So this is 0.5 or 0.50. As you're looking at your decimal numbers and your percentages, because you're going back and forth, do I move it right 2 spots? Do I move the decimal left 2 spots? Whichever. Your number here that you end up with for the decimal number is always going to be smaller than what you have for the equivalent percent. Meaning, if I ignore the percent symbol, 0.125 is smaller than 12.5. Okay, if you did it the other way around, you'd get a bigger number, and then that should be a red flag for you. All right, today we're going to be talking about divisibility rules. These are going to be very, very helpful as you progress through all your math classes, and it's very easy to use these instead of just kind of guessing and checking your way. That takes a lot of time. So we can know that any number is divisible by 3 if the sum of the digits, meaning if we just add up all of the digits, if we add them all up and that answer is divisible by 3, the original number is divisible by 3. So we're going to look at an example. You've got you and 2 friends who want to split the cost of tickets to a football game. The cost of the 3 tickets is $114, and we want to know, can you divide that evenly amongst all 3 people? Okay, when we're saying evenly in this case, we want full dollar amounts. So what we're going to do is we're going to take 114, and we'll add up the 3 digits, the 1, and the 4. When we add those up, we get 6, which is a much easier number to divide. And we ask ourselves, can we divide 6 by 3? And we can. Now, they're going to say it a little bit different. They're asking if when we divide, we get a remainder. So that's why it says no. And I'm just saying, can you divide by 3? Yeah, you can divide by 3 evenly. So since you can divide 6 by 3, okay, like 6 divided by 3 is 2 exactly. That does not mean that 114 divided by 3 is 2. All that is telling us is that you can divide 114 by 3, okay? Otherwise, if you wanted to know, you'd have to break this thing out. You go, okay, the 0, 3, 9, 2, 4, 6. That's not a 6, that's an 8. So it's 38. It'd be $38 for each of you. All right, so we have divisibility rules for 2. If it's an even number, so if the last number is divisible by 2, so if it ends in a 0, 2, 4, 6, or 8, you could divide by 2. For the rule for 3, if you add up all of the digits and you can divide by 3 for that, then the original number is divisible by 3. For the dividing by 4, they're going to say the last 2 digits are divisible by 4. So I could look at 2, 4, 6, 8, 10, 12, 14, 16. This is a really long number. So it would be like that. Okay, can you divide this by 4? I don't want to go through the process of dividing by 4 and finding out that I can't. What I can do is just look at these two digits. I know 16 is divisible by 4, so this entire ridiculous number would be divisible by 4 as well. Another way you can do that is, well, I know it's even because it ends in a 6, so I can divide that whole thing by 2, and I'll get an answer. If I can divide that number by 2 again, then I could have divided the original number by 4. Dividing by 5 is one of the easier rules. If it ends in a 0 or a 5, you can divide by 5. Dividing by 6 is one that students forget every year. Since 6 is 2 times 3, in order to divide by 6, you have to be able to divide by 2 and by 3. So use these two rules here. Does it end in a 0, 2, 4, 6, or 8? And if you add up all the numbers, is that number divisible by 3? If both of those things are true, you can divide the original number by 6. Dividing by 9, kind of the same idea as when we were comparing 4 and 2. Okay, because 4 is 2 times 2, 9 is 3 times 3. So if the sum of the digits is divisible by 9, then you can divide by 9. Or if you can add them all up, divide by 3, cool. And you do it again, and you can still divide by 3 again, cool. Then it could have been divided by 9 originally. And then 10 is the easiest rule of all. If it ends in a 0, you can divide by 10. That's it. So for the divisibility rule for 3, we're going to say let v equal the sum of the digits in a number. Okay, it's just a variable v. If v is divisible by 3, meaning if v divided by 3 has no remainder or a remainder of 0, then the original number can be divided by 3. Divisibility rule for 5 is going to be kind of the same thing, where we're going to set up a variable. We're going to say let p be the last digit in a number. If p equals 0 or if p equals 5, then you could divide by 5. So here it says use algebra to identify the different divisibility rules. The variable n represents any integer. Circle the numbers that apply. Show your work. These are terrible instructions in my opinion. So all I want you to do is look at this thing right here. N is a number. So this is saying n divided by 2. These are all of your possibilities for n. Which numbers can you divide by 2 and get no remainder? That's all that's asking. In number 2, which numbers make both of those true? So which numbers can you divide by 3 and also divide by 2? And then for these, they want you to write your divisibility rule. Okay, all you're going to be doing is writing, scroll back up here, writing one of these things. All right, and then I think you've got a couple more down here. So pause the video, work out those few problems, then come on back and see how you did. So, which numbers have no remainder? For n divided by 2, it's those numbers, all of the even numbers. This is the divisibility rule for 2. Okay, if you're dividing by 2, it has to be an even number. For n divided by 3, I have to add up all of the digits and have that number be divisible by 3. So if I do 1 plus 1 plus 0, that's 2. That does not work. 1 plus 1 plus 1. Oops. That equals 3, so that one does work. So I know that the next one's not going to work because that's going to add up to 4. The next one's not going to work. It's going to add up to 5. That one's going to work because 1 plus 1 plus 4 equals 6. That was the example we did. I'm going to continue on, and it's going to be every third number. But that's not all of the things I needed to do. Now I also need to highlight the ones that I could divide by 2 with no remainder, which would be these ones. So which numbers did I highlight both times with both green and yellow? 114 and 120. This is the divisibility rule for 6. If you can divide a number by 3 and by 2, that means you can divide by 6. And here, which ones can you divide by 5? Has to end in a 0 or a 5. Those are your options right there. This is the divisibility rule for 5. There's no work to show. It's just, does it end in a 0 or 5? So next we're going to solve problems involving percent increases where they're given the percent increase and the original amount. So the number of people who watch movies on the internet is increasing. In 2013, 16 million people were watching movies online. By 2014, that amount had increased by 75%. How many people were watching movies online in 2014? So we're still going to be using change over original equals percent over 100. But I have to think about how I'm changing, all right? So I don't know the amount that changed. I'm going to put X. The original amount in 2013 was 16 million. I'm going to write 16 million just like that instead of out like all the zeros, because I'm only really caring about the 16 part. I can just put million at the end. It increased by 75% out of 100. All right. Like I've shown multiple times before, 75 out of 100 is 3/4. I can go from 4 to 16 by multiplying by 4. So 4 to 16 million would be multiplying by 4 million. So this is also times 4 million. So 4 million times 3 tells me X equals 12 million. That is not how many people are watching movies online now. That's the change. Since it increased tells me to add. So I'm going to take my original amount, which was 16 million. I'm going to add how much changed, which is 12 million, for a total of 28 million. So how many people were watching movies online in 2014? There were 28 million people watching movies online in 2014. And hopefully this number kind of makes sense, okay? If it increased by 75%, that's a lot, okay? Increased by a whole bunch of people, increased by 12 million people. More people should be watching than were originally. All right, so you've got a couple problems here. It looks like 2 problems. I want you to solve the following percent increase problems. Make sure you use the total, whole, or 100% and the change for the proportions. So go ahead, pause the video, work these out. When you think you've got it, unpause and see how you did. For all of these, you're going to be using that same proportion. So number 1, Craze Car Wash cleans between 50 and 70 cars per day. They charge $10 for the wash and $12 to clean the inside of the car. Regular customers get a free car wash every 20 washes. On Wednesday, Craze Car Wash cleaned 60 cars. On Thursday, they cleaned 20% more cars than on Wednesday. How many did they clean on Thursday? So there's a lot of useless information. I don't care about that one. I don't care how much they charge. I don't care how many washes someone gets to earn a free car wash. What I care about is just from here on out. That's realistically the question. So my original amount, what they did on Wednesday, was 60 cars, and we don't know how many more they cleaned, but they had a 20% increase. That's 20 out of 100. All right. You could divide this by 5, or you could have simplified to 1/5 and then divided by 5 or multiplied by 12. It really didn't matter. Either way, you're going to get X equals 12, so they had an increase of 12 cars. So how many did they clean? 60 plus 12 is 72. They cleaned 72 cars on Thursday. All right. Number 2, people who fly a lot get bonus miles that they can use to get free tickets and other kinds of upgrades. Don't care about that. Mara Johnson flies a lot for business. Still don't care. She usually flies back and forth between Chicago and Dallas for business. Still don't care. Each trip is about 1,600 miles or 1,600 miles. Might care about that. Last year, she flew 50,000 miles for business. This year, she expects to increase her business travel by 20%. How many miles does she expect to fly? So I don't care about the 1,600 miles part. I care about how much she's flying in a year. So her original amount is 50,000, and we don't know how much it changed by, but we know she plans on increasing 20% out of 100. Now for this one, you could try to simplify, or I can just multiply straight across. Okay, if I'm looking for 1 to 5, that'd be times 5, but I have 2 zeros, and over here I have 4, so I need 2 more zeros. So times by 500 to get x equals, well, 5 times 2 is 10, but there are 3 other zeros, so x is 10,000. That's how much she increased. So she was at 50,000, and it increased 10,000. That becomes 60,000. So Mara expects to fly 60,000 miles this year. All right, make sure you're working on your day 9 homework, and I hope everybody has a fantastic day.